Okay, yeah. So for our final project, we created a maze game playable on the PIC, and we can use the Python interface to actually like attach our key presses to the movements of the player. So the game has three difficulty levels, as well as two-player mode, so that two people can play it on the same computer, and also time trial mode, so that we can keep like a high score track of how fast you complete a maze, just for the more competitive people that want to play this game. So just design kind of approach that we took is just incremental design. So we started just generating the maze in Python and use ASCII art, like using ASCII art representation, just to make sure that our algorithm was correct. And then after that, after we were sure about that, we ported our code over to C, and then we used the Python GUI serial, the multi-line serial box to verify that that code is correct. And once we did that, we started actually drawing the nodes on the TFT, and then to incorporate different difficulties, the harder mazes were generated with more nodes, making them smaller and then more confusing. And after we got that working, we added player movement, two-player mode, and then time trial mode.
Um, so to generate the maze, we used a modified version of Prim's algorithm. We decided to start with a node in the middle, like a randomly selected node, because we found it made better mazes than choosing like the starting node in the top left corner. So once you have the starting node, you add all of the nodes around it, so top, bottom, left, right, to the frontier set. You then randomly select a node from the frontier set to be your selected node. Once you have your selected node, you knock down the wall between the selected node and the current node to add the selected node to the maze. And you add all of the neighbors of the selected node to the frontier set. To determine which nodes of a frontier node can be added to the frontier set, we have a few helper functions, but basically the criteria is that A, it's not already in the frontier set, and B, that it has all of its walls. The wall check isn't necessary for correctness, but one thing that we notice is if you don't check if it has all of its walls, you can end up with loops in the maze, which isn't necessarily a bad thing. It's just not an implementation that we wanted. So this iterates over and over again, adding a single node to the maze and growing the maze one node at a time until all the nodes have been added to the frontier set and removed from the frontier set. So until the frontier set is empty, meaning that all nodes have been added to the maze and the user can access any point in the maze.
Cool. Yeah. So as far as hardware, our project was a little bit more on the CSE side. So obviously we have a lot of like algorithm design, but we use the TFT as well as timer 2 in this project. The way we use the TFT essentially is that we determine like from our difficulty level how many nodes we have in our array. So we have a couple of different sizes like 12 by 9 or 24 by 18, just to kind of keep the grid sizes squares. And from there, we basically draw the whole grid onto the TFT, and then using the knockdown wall concept that Kyle was explaining, we just erase that wall between two grid cells once the maze, and then once we iterate through the whole algorithm, the maze is formed on the TFT. Then we draw the user's icon in the top left corner. Always we start there. And then we basically get some serial messages from Python when the user presses a key, like the WASD keys, which gives us like the user's intended direction. And then based on the walls that are still existing, we determine whether that's a legal move or not. And if it is, then we erase and redraw the user's icon in its updated location. We use timer 2 for the time trial mode. So if time trial mode is enabled, we'll start timer 2 as soon as the new game button is pressed on the Python interface. Timer 2 is set up to interrupt every 10 milliseconds so that we can determine the length of time that it takes a user to complete the maze down to 1/100th of a second. And then once the user's icon enters the bottom right corner of the maze, that bottom grid cell, the maze is considered complete and will output the time and update the high score if it was better than the existing high score.
Cool. So how long does it take to generate a maze?
So we can actually see that.
Yeah.
Oh wait, do you actually want to share? You want to share from the pic? Yeah. So we can see like the Python GUI also.
Yeah.
Yeah. So it actually, it's pretty fast. You can kind of see it. So you can.
Screen sharing.
Oh, can you enable screen sharing?
Oh yes, absolutely. Sorry about that.
Yeah, you can actually see it. You can actually see the entire grid being drawn, and then I mean, yeah, we can show it, and then you can kind of see like some walls being erased, and then the maze actually generates. It's kind of cool. Oops.
Oh my goodness.
Yeah. So can you guys see both our pic and the Python GUI?
If possible, it might be easier to see if you turn off the camera on Zoom and then open the camera view on the PC.
Okay, yeah, it's a good idea. Okay, yeah, so that's if we generate an easy maze. Yeah, so you can, right when we press new game, you can see the entire grid being drawn, and then it kind of
Yeah.
updates iteratively until you get the full maze. If you slowed it down, you'd actually be able to see individual walls being erased, but like obviously we can't see that.
It's pretty fast.
Yeah.
Yeah. You see, you're using some random number generator to knock out walls using rand or
Yeah, and we picked a random seed based on, I think it was like the based on PT get time, just so that we never get the same mazes once you hit new game.
cool.
These are not obvious mazes either. I'm just sort of
Yeah, this one's
scrolling through it
very
with my
difficult.
eyes. I'm not.
we
finding the
can
right
start with
path.
easy ones just so we can see like gameplay. All right. All right, so yeah, we can see this is easy, one player, and time trial mode is not enabled.
You talk about the how it like jerks.
Oh yeah, sure. So one thing that we were experimenting with when we were drawing the player is like what happens if the player moves out of the intended tracks. So the intended tracks are always going to be in the middle of a node, and you can never go closer to a wall than half the node width. And the reason for that is if you do get out of the track, like it's sort of undefined behavior in our program, and you can kind of just move wherever you want then, and you might erase walls accidentally. So what we did to combat that is, yeah, we only let you move towards a wall until there's like a width and a half, or sorry, node width over 2 left. So you can only basically move to the middle of the node if there's a wall on the other side. If there isn't a wall on the other side, so like here, let's go to an example. So yeah, where Kyle is right now, you can see to the right, like to the upper right, there's no wall there, right? So if Kyle wanted to go right, the way that we initially had our code, he would have to be exactly in the middle of the node right there. And that's obviously not feasible for like anyone playing the game, and if you want to play fast. So what we did is, if you're in a node and the pick to text that you're trying to move towards a place where there is no wall, you basically snap the player to the middle of the node, and then yeah, you can kind of see it there. Yeah. So okay, yeah, sort of like that.
Yeah.
Yeah. So and that helps with just keeping you in the tracks of the game, and it also looks kind of nice that way. Yeah. So something like that.
Very
It's harder.
nice.
It's a little harder to see when the screen's a little bit smaller, but yeah.
So you want to finish the maze?
And then if you navigate into the end of game tile, what happens?
Yeah, I can talk about that.
Hey, you wanna
Yes.
win the game?
I'll try. There might be a wall here. We're talking about it right now.
Yeah. Let's see. Okay. Yeah. So, you want to talk about?
Okay, so right at the end, there's a feature in our basically like you can't really tell from this maze whether you're supposed to enter that last cell from the right or from the top. So Kyle, do you want to just try to enter it from the right? So are you getting stuck there? So there's actually a wall right in front of that cell. And you're supposed to be entering it from the top where Kyle is right now. We decided to leave this in because we thought it was kind of fun. If you're racing your friends and you think you have the lead, and then you have to kind of skirt back around the other side because you can't see the
Yeah.
ball there. So we decided to leave that in because we thought it was a fun little feature that made the game more enjoyable for us at least.
Cool.
So now I guess we'll show you a time trial mode with 2 players. So we'll have Dylan and Kyle play on the same keyboard. We'll do an easy one, so hopefully they can see it. So the player 2 is in blue there, and player 1 is in white. And then based on which player gets to the end first, it should output P1 or P2 wins. So their player 2 wins, and we decided to allow the user to kind of just like erase over the win message, just because it felt like an old retro style game where you can kind of do that. And we thought it was cool to allow the user to continue interacting with the maze even after the game is over. And then from this point, if you wanted to reset it, all you'd have to do is press new game with your desired modes, and then it'll restart.
Looks really nice.
It's really solid. The motion is quite smooth, so it's single pixel motion.
And I'm noticing too that every time it generates a new maze every time. So each maze is randomly generated, and then each subsequent generation is also new. So clearly the random seed is somehow being updated. Are you randomizing the seed in some way?
Yeah, so I think Dylan mentioned that when you hit the new game button, we do a call to PT get time, and we use that to set the seed for generating that particular maze. So every single time that you hit new game, we change the random seed.
Gotcha. So you're using sort of human interaction times as a source of randomness. Nice.
Very nice.
Yeah, one of the other features we had, this goes along with the time trial. On the Python GUI, you can see the like the high scores for each difficulty. Basically, whenever you finish the maze, it'll send the difficulty and the time to the Python interface, and then the Python interface will compare the current value in a high scores text file, and if it's less than for that given difficulty, it'll write it in, so you can kind of have like a leaderboard going.
So
And
the non-volatile memories on the PC.
Yeah, so it'll save between iterations.
Cool.
Really cool.
So does that file survive through reset?
Yeah.
Okay. Nice. Very nice. It looks, I mean, it's really smooth.
I'd love a handheld version of this. It would just be a fun thing to have. It's cool.
So I think Kyle's going to try to set the easy high score. We might have to wait for a certain maze to generate that's a little easier, but this one actually would work. Okay, so there you can see that easy just updated to 7.45 seconds.
Yeah, it was previously 11 something. I think I noticed. Yeah.
And if he did that again without time trial enabled, we don't send the time that it took at all. So Python can't update any high scores unless you have time trial mode enabled.
Slick.
Really cool. Thank you guys. That's a great project.
Yeah,
Thanks.
It's well thought out. It's well executed. It looks completely playable. Very nice.